All right, guys. So uh, off to the side here, do some more U sub trig stuff here. Off to the side, over here in this little area, I've created kind of the idea of what we have going. So if we see this inside the problem, we're going to let x equal a tangent of theta, and the whole goal is to create a squared secant squared theta. So we're going to get a secant theta. Same thing with sine. When we see this is an a minus x squared. It gives us, we want to set it x equal to a sine theta, and then our whole goal is to create a squared cosine theta so we can simplify it. Same thing here. So let's tackle this one here. So we see, let's rewrite this here. Let's rewrite this as, I'll put dx over here, and I'm going to put 1 over, and I'm going to do 2 squared plus x squared. So there's my a. Now I've got an a squared plus an x squared. A squared plus an x squared. That's going to be this one right here. Okay, and I'm going to do this kind of the long way. So if I take a and I say I want a to be, so we got x squared, a squared plus x squared. We're going to use this one right there. So a is equal to, sorry, not a, I'm going backwards here. Oops, that's a squared. I'll just leave it. X is equal to a, which is 2, times the tangent of theta. That means dx is equal to 2. My brain just went dead. What's dx equal to? Secant squared. Uh, secant squared. My brain just went completely dead. Secant squared theta. D theta. So that's my dx. And then off to the side here, let's do our, we do it in a different color here. Let's do it in bright blue. Let's do our triangle in case we need it. So we know that theta is equal to the tangent negative of x over 2. So that means theta's here, x is here, and we've got opposite over adjacent, and then this becomes the squares of both of them added together. Okay, so now my triangle's set up. I know what theta is in case I need it. I can find any trig function in case I need it based on this. So now we can just kind of work our way through this. So let's go ahead and go back to this piece right here. So I'm going to go 1 over, and I'm going to write this a little bigger this time. So I have this piece here, which is my 4, and then that is going to be plus this right here, my 2 tangent theta squared. So then I'm going to get plus 2 tangent theta squared. And that's going to be all multiplied by my dx right here. And so my dx is 2 secant squared theta d theta. Okay, now here's where all of this comes into play. So now I get, we rewrite it here, bring that down, and then this now becomes, 4 tangent squared theta. Okay, this now becomes 4 tangent squared theta. And then and then this, we still keep going to secant squared theta d theta. And as I keep working this down, this is where it makes a major change. So I'm going to go ahead and go to a different color here. This is where it makes a major change. This here now becomes what we were looking for right here in this next step or two. I'm writing all over my cord. No wonder I can't do it. This, in the next step or two, this is where we get our piece that we want. So we get the integral of 4 plus, oops, not plus. These are all the long steps of 1 plus tangent squared theta, because I factored my piece out there, my 4 out, because what I want is an identity that gives me, secant squared theta. That's my goal. When I change it to a tangent theta, my goal is to make a squared secant theta, which it happens right here. And so what we end up with is this becomes secant theta. So that becomes secant squared theta. And so now I've got a squared and secant squared theta, which is my goal. This is a squared, 2 times 2. Here's my goal of secant squared theta. So now I end up with a little bit easier of an equation to deal with, which is 1. Let me rewrite that now. Let me put this over here. This becomes 2 secant theta, right? And then the top becomes 2 secant squared theta d theta. So I just kind of cleaned it all up there. Okay. So now this would be an absolute value here. And so because of secant squared, you can't have the negative in that square root. So since this would technically be the square root of secant squared theta, we can't have a negative in here. So it's got to be the absolute value. So let's go and finish this thing out here. So then we end up with, let's finalize this thing. We end up with the integral. We clean this up. 2's cancel. And we're left with secant theta d theta. So now we can integrate secant of theta. And that's one of the extra ones on the side. So the secant of theta is the natural log of the absolute value of the secant of theta plus the tangent of theta, and that would be plus c. Okay, so all of this stuff, all these steps are the goal of creating right here. Let me do this highlighter. Is the goal of taking this bottom piece and converting it into something that's really easy to simplify. And then the whole goal is it should be able to kind of deal with tackling this all the way to here, and then we can just apply a regular integral to it. Now we have to take our piece here. So let's go ahead and finalize this thing. So this would be the natural log plus c. Now I just need to figure out what secant is. Secant is the inverse of sine. So opposite over hypotenuse. So it's going to be hypotenuse, which our hypotenuse on the triangle up here is 4 plus x squared, all over x plus our tangent of theta. And our tangent of theta is equal to x over 2, right? Because I just tangent of theta is here, divide out. Tangent of theta is equal to x over 2. And what do I got here? Oh, secant doesn't go with sine. That's wrong. Hey, what am I doing? It's a 2. I was like, oh, this doesn't feel right. There we go. It's a 2. So secant is 1 over cosine, not 1 over sine. And so then if I clean all that up, we end up with, if we multiply through, because this is a constant, really, so it becomes a 1/2. So this is really C1. Because if I factor out a 1/2, right? If I factor out a 1/2 and can bring it out front, it ends up becoming another constant. So we can clean this up by saying this is the natural log of square root of 4 plus x squared plus x plus C2, which ends up being C, because I took the 1/2 here out and combined it with that one. So that's kind of the idea. So these 4 things right here, guys, are the key pieces to it all. So we'll throw another one up during class and see what you guys think. But other than that, great job.